Okay, this is problem number 4 from your class examples in section 1.2. It says solve the following equation by completing the square. X squared plus 6x equals 55. Alright, the background for completing the square. This is kind of the math that goes into it. These are the words. Express the quadratic equation in the form on the left. So you want your x squared term, your x term. Quadratic linear equals the constant. And then you divide b, which is the coefficient of the x, by 2, and then square it. Once you do that, you add it to both sides. Okay, so you write it as the perfect square. The left side is the perfect square. Then you will go back to the square root method and actually find the solution. And this is just a reference for the square root method. You're at this point. Your step 3 there becomes your step 1 here. Take the square root of both sides. Keep in mind that plus and minus. Okay, when you take the square root of both sides, the radical and the square cancel each other out so that it removes the square, and you're left with just x plus b over 2. Allow for the plus and minus here. You want to isolate the x, so move the b over 2 to the other side. And you can see this is kind of forming the quadratic formula. If you wanted to go on through, you could actually turn it into the quadratic formula. But we don't need to do that to solve this problem. Okay, the actual problem. We've got it set up with the squared term and the x term. So the quadratic and the linear term are located on the left, the constant on the right. We divide b, which is 6, by 2 and square the result. 6 divided by 2 becomes 3 squared, and 3 squared equals 9. We add that 9 to both sides. This is the perfect square trinomial, and we want to now write the left side so that it is looks like the perfect square. So x plus 3 squared, which is the square root of x squared, the square root of 9, the middle sign, quantity squared. And 55 plus 9 is 64. Okay, you're at the point to use the square root method now. So take the square root of both sides. Be sure you remember the plus and minus. The square root of this quantity squared simply cancels out, and you're left with the x plus 3 is equal to plus or minus the square root of 64 is 8. We move the positive 3 to the other side so that we can isolate the x. Break it down into two little equations so you can solve. Negative 3 plus 8, negative 3 minus 8. Negative 3 plus 8 is 5. Negative 3 minus 8 is negative 11. These are your two actual solutions to the problem. So that would be the answer that you would plug in for this problem.